Hello students, in previous lecture we have solved the examples which is based on synthetic division as well as the value of polynomials. We calculate the value of polynomial for the given value of variable, and that concept is also useful in the next new concept, that is remainder theorem and factor theorem of polynomials. Then in this chapter or in this video, in this lecture, we are going to solve few examples which is based on remainder theorem as well as factor theorem. We will first understand what is remainder theorem. Then see here, let us consider Px is a polynomial and which is divided by, that is divisor, that is x plus a. Then see here, if Px is any polynomial, if it is divided by x plus a divisor, then here x is equals to minus a. That means here for the value of x is equals to minus a, then p minus a, value of that polynomial, value of given polynomial px, and here the p minus a is also remainder of polynomial px. Then that is the remainder theorem. Then we will solve few examples which is based on that remainder theorem. Let us solve one of the example, that is here px is a polynomial, that is here 3x square plus x plus 7, and which is divided by, that is x plus 2. Then see here 3x square plus x plus 7, which is a dividend. See here, dividend, that is 3x square plus x plus 7, and here divisor is x plus 2. Then here we will get quotient and remainder after solving this example of division. Then we can divide this polynomial by x plus 2 by two ways, that is synthetic division method as well as by classical method. Then all of you studied about that. We will solve this example by both method. Then see here, dividend, that is 3x square plus 1x plus 7, which is written in the index form and which is divided by x plus 2. Here x plus 2 is a divisor. Therefore, see here, the method all of you studied about this in previous lecture. Therefore, here first of all we have to divide that 3x square by 1x, that is the first term of divisor, and here we get, that is 3x. That 3x is written in the quotient, and then we have to multiply that x plus 2 by 3x, and therefore here we get 3x into x, 3x square, which is written below the like term, as well as 3 plus 3x into 2, that is 6x, which is also written here below the 1x. Then we have to change the signs of those terms to subtract that terms from this those terms. Then 3x square minus 3x square, we get cancelled here, 0. Plus 1x minus 6x. See here, plus 1 minus 6. Here we get minus 5. Therefore, minus 5x is there. Then plus 7, which is taken here. Again, here degree of x is 1 and minus 5x of which degree is 1. Therefore, we can divide that minus 5x by x. Here we get minus 5. Therefore, we have to write the minus 5 in the quotient. And here that x plus 2 is multiplied by minus 5. Therefore, here we get minus 5 into x, minus 5x, minus 5 into 2, that is minus 10. Therefore, here those terms are written below those two terms. That is here to subtract those terms from these. Then we have to change the sign of both terms for subtraction. Then minus 5x and plus 5x get cancelled. Plus 7 plus 10, that is 17. Then here division get completed, and therefore here we get quotient 3x minus 5. 17 is a remainder. Then the same division process can be done by synthetic division method. Then by synthetic division method, therefore again we have to write that dividend in index form. Therefore here 3x square, again here 1x raised to 1, 7x to x raised to 0. Therefore here we get that index form of the dividend. Therefore we get the coefficient form of that polynomial or dividend, that is here 3, 1 and 7. And here the value of a, therefore here a is equals to minus 2. The opposite number of plus 2 is minus 2. Therefore here that minus 2 is written here, and therefore here we get 3 into minus 2, that is minus 6. Here 1 minus 6, that is minus 5. Minus 5 into minus 2, that is plus 10. Therefore 7 plus 10, that is 17. And the last digit, which is known as remainder here, that is the remainder. And here we get quotient in index form, that is here 3x minus 5 is the quotient. Then here we get the same quotient and remainder in the synthetic division method also. Then see here, all of you have also calculated the value of polynomial, and all of you have solved the examples which is based on value of polynomial. Then here the value of a is equals to minus 2. That means here for this polynomial, that is px, here 3x square plus 1x plus 7, for this polynomial, if x is equals to taken, that is minus 2, then for the value of x is equals to minus 2, then p minus 2 is the value of polynomial. And therefore we have to find out the value of polynomial for x is equals to minus 2. Therefore here p minus 2 in bracket minus 2. Therefore here 3 into, here we have to put the value of x, that is minus 2 bracket square plus 1 into minus 2 plus 7. Therefore here p minus 2, that is polynomial in minus 2, that is value of polynomial for the value of x is equals to minus 2. Then here 3 into minus 2 square, that is 4, plus 1 into minus 2, minus 2, plus 7. And therefore 3 into 4, that is 12, plus minus 2, minus 2, plus 7. Then here 12 minus 2, that is 10, plus 7. Here we get 17. Then see here, the p minus 2, that is the value of polynomial, is 17. Here value of polynomial for x is equals to minus 2 is 17. And see here, focus here, that the same polynomial when it is divided by x plus 2, that is here x plus 2 is a divisor, and therefore here a is equals to minus 2. That means for the value of minus 2, the value of this polynomial is 17, as well as if that polynomial is divided by x plus 2 by any one of the method, then remainder is also 17. That means here if x plus 2, here if x plus 2 is divisor and which divides polynomial px, then here for p minus 2, which is the value of polynomial, is the remainder of that example. That is the remainder theorem. That means if polynomial px is divided by x plus a, then the remainder is p minus a, value of that polynomial, means that the same which is of value of that polynomial for x is equals to minus a. Then that is about the remainder theorem. Then one more concept, that is here factor theorem. That is the factor theorem. Then see here, the one of the example, which is the example which we have solved before that of division of polynomial, in which remainder is 17. Then focus here, here px is a polynomial and which is divided by x plus a divisor. Then p minus a is the value of polynomial, and p minus a also remainder of that example, and if see here p minus a is equals to 0, if it is, that means here remainder is 0. If remainder is 0, then see here x minus a, then x plus a is a factor of given polynomial px. Then see here in this example, here remainder is 17, therefore here x plus 2 is not the factor of 3x square plus 1x plus 7. Then that is about the factor theorem. Then we will solve few examples which is based on remainder theorem as well as factor theorem. Let us px is an example which is given here, x cube plus 4x minus 5, which is divisible by that is x minus 1, and x minus 1 is a divisor. Then we have to find out the remainder. Then find the remainder by remainder theorem. Remainder theorem. Then see here px here, which is divided by qx, that is x minus 1. Therefore here by using remainder theorem, therefore here the value of a is equals to opposite of that minus 1, that is plus 1. Therefore here the value of that px for a is equals to plus 1. Therefore here x cube plus 4x minus 5, and here pa is the value of polynomial, as well as pa is the remainder, and therefore here p, the value of a, that is plus 1, p1 is the remainder of given example of division. Therefore here p1 is equals to, then see here x cube, that is 1 cube, plus 4 into 1, that is 4x minus 5. Therefore here p1 is equals to 1 cube 1 plus 4 into 1 4 minus 5. Therefore p1 is equals to 1 plus 4 5 minus 5. Therefore here p1 is equals to 0. 5 minus 5 0. Therefore here remainder is 0. And by factor theorem, here x minus 1 is a factor of that is polynomial x cube plus 4x minus 5, that polynomial. That is the one of the example that is related with the remainder theorem as well as factor theorem. Then one more example which is given here in the problem set as well as the examples which are given in the practice set 3.5. We will solve few examples like those examples given in those problem set and practice set. Example which is given, that is using factor theorem, we have to find out that x plus 3, is a factor of polynomial, that is px is equals to, that is x square plus 2x minus 3 or not. Then see here, using factor theorem, x plus 3 is a factor of this given polynomial or not, we have to find out. Then see here, first of all we have to write the polynomial px is equals to x square plus 2x minus 3, and here qx, that is the divisor, x plus 3, and using factor theorem, we have to determine whether that x plus 3 is a factor of this polynomial or not. Therefore, we have to find out the remainder of this example. Therefore, using remainder theorem, we can get the remainder of this polynomial, that is p minus 3 is the remainder of this example, because here x plus 3 is there. Therefore, here p minus 3 is the remainder of this example. Therefore, here we have to find out the value of p minus 3 is the value of polynomial px for x is equals to minus 3. That means we have to put the value of x is equals to minus 3. Therefore, p minus 3 is equals to, see here, x square plus 2x minus 3. Therefore, putting the value of x, that is minus 3 square plus 2 into minus 3, minus 3. Then simplifying, here we get minus 3 square 9 plus 2 into minus 3 minus 6 minus 3. Therefore, here 9 plus minus 6, that is minus 6 minus 3. 9 minus 6, that is 3 minus 3. Here we get p minus 3 is equals to 0. And here p minus 3 is the remainder. And here we get remainder is equals to 0. But using factor theorem, if remainder is 0, then here x plus 3, therefore x plus 3 is a factor of, that is here polynomial x square plus 2x minus 3. That is the examples which is based on factor theorem as well as remainder theorem. And this type of examples which is given in the practice set 3.5 and problem set 3. You should solve the examples from practice set 3.5. Thank you.